0.15 kilograms times the velocity of the bullet, and we can find out how fast the bullet was moving before it hit the block. 280 meters per second is about 600 miles an hour. So totally reasonable. It's a subsonic bullet. Doesn't break the speed barrier. Doesn't break the sound barrier. I know it is pretty weak. It'll do a little bit of damage, I guess.
Dude, I have a crossbow.
Okay, next. So now you can do the math. Can I erase that over there?
Yes.
All right. Reverse inelastic collision. In a reverse inelastic collision, you have two things breaking apart. As what happens with a bow and arrow or a crossbow. So consider a reverse inelastic collision, a 225-gram crossbow. That's a really light crossbow. Oh, the bolt, okay. 225-gram crossbow bolt is fired at 75 meters per second. Yeah, this is like you have a crossbow, you hang it on a string, then you pull the trigger, and the crossbow goes this way and the bolt goes that way. Does that make sense? Same kind of thing if you were sitting on a frozen puddle and you threw, you had a UPS package and you threw the UPS package that way, you're going to go that way. Or sometimes you see in bad sci-fi, they're like, oh no, he's floating away from the space station. He's going to float away forever. He's like, I will throw my backpack that way and I will go that way. Yeah.
But it's right.
It's right, yeah, but I'm just the movie I'm thinking about is crap.
Is it Wall-E?
No, but Passengers is actually pretty good. Passengers is actually one of the most accurate movies, except for the very, very end. Passengers is pretty good.
What about with the fire extinguisher? Would that work?
Yeah, absolutely. With Wall-E and the fire extinguisher, it will absolutely work. Because basically what he has is a jet engine. He has a rocket engine.
What about Interstellar?
Interstellar is pretty good too. Yeah, Interstellar is pretty accurate too.
Also realistic?
Everything but the scale. The scale of, in order for time to be dilated that much, gravity would have been so much more that you wouldn't be able to survive. But time does dilate with gravity, and that's what we'll be talking about in about 3 weeks. So anyway, so you have the bow is going that way and the bullet is going that way. Ladies and gentlemen, reverse inelastic collisions are very, very easy because their overall, in this class, the overall initial momentum is 0. So you have the crossbow and the bolt, and they initially are at rest. And the bolt goes this way and the crossbow goes that way, so their initial momentum, 0. Which means the momentum of the bolt and the momentum of the crossbow have to be what? Equal to each other. Super great. So you can just basically say momentum bolt, or sorry, mass bolt times velocity bolt equals mass, I got these backwards. Mass crossbow plus velocity crossbow equals mass bolt times velocity bolt. Okay? Because they initially were at 0, whatever went that way had to go that way.
So the velocity of the bolt's going to be more than the crossbow.
Absolutely, because the mass of the crossbow is a lot larger, it will have less velocity. If you don't have a crossbow at home, you can practice this by taking a shotgun and hanging it from your garage ceiling.
I can do that.
Yeah. There you go.
Stand on this side of the shotgun with the butt of it facing you. Pull the trigger so it goes boom.
Then you get hit by the recoil.
Guys, are you practicing this? 3.67? 3.67? Can I round that to 3.7? All right. So let's unpack this. What this means is you initially have...
It's 2.7. Okay, maybe I did it all wrong there.
Don't fight it. Just, you know. Hey.
Times 75
Divided by 4.6.
is
It's only 9 pants.
it's not 4.6 divided by it's the other way. Okay, yeah, I get it.
Are we good?
Yeah.
We're good? Okay, so let's unpack this. You have a crossbow.
Wrong.
Oh, here you go. There we go. You have a crossbow, no momentum. So initially, the whole system has 0, which means when we pull the trigger, whatever momentum the crossbow bolt has, the crossbow also has to have. So whatever MB the crossbow bolt had, the crossbow also had to have. Make sense?
Basically, when you shoot a gun, you just got the momentum of the bullet in each moment.
Bullet plus gas, yeah.
Except you,
Is-
like,
'cause
It's a larger mass.
it's not
Yeah.
free swinging.
Exactly, it's not free swinging, although I have seen that before. There are pictures online of people who are like holding a shotgun like this, like in the movies, and they pull the trigger and the hook and go, phew.
So wait, if
Rifle,
you
like
pull
pistol
the
grip
trigger and it
shotguns.
was on a string, it would actually hit you with the force of the bullet?
Not the force, the momentum.
So it hurt.
Yes, of course. It wouldn't be the force of the bullet, it would be the momentum of the bullet.
So I don't even need to shoot someone. I can just like turn the gun backwards and shoot the gun half.
You could, yes. It would not feel good. Okay. So last exercise for today, with the remaining 8 minutes we have. So consider, this is also a very common reverse collision. A 45 kilogram girl on a 4 kilogram skateboard is moving forward at 8 meters per second before she jumps off. A little more complicated because now she has initial velocity. It is a reverse inelastic collision, but the object has an initial momentum. How fast is the skateboard moving backwards after she leaps off at 9 meters per second? Which side should I erase, left or right? Left, okay. So we have two situations. We have girl and skateboard. Initially 1 unit. Okay, so the girl's 45 kilograms and on a 4 kilogram skateboard. And both of them are moving at 8 meters per second. I need a new blue pen. So we have a total mass of 49 kilograms and a total velocity of 8 meters per second. So we know how much momentum is in the system. There are 2 ways to go about doing this. We're going to solve them both ways. Yeah, well no, for the overall answer. We're going to solve it 2 ways if we have the time. So we have a 45 kilogram girl on a 4 kilogram skateboard. She's moving forward at 8 meters per second. So using this information, we can calculate how much momentum is in the system by taking the 49, multiplying it by the 8. M1, M2, V1, V2, P1, P2, 392? Is 49 times 8 392?
Yes.
Anyone else want to confirm that?
Correct.
All right. So the system has 392 kilogram meter per second of momentum in the system. Okay, so far so good? Now, after collision, the skateboard goes back. Oh no, she leaps off. She leaps forward at 9 meters per second. Okay, so after collision, the V of 1 is now 9 meters per second. And the mass of 1 is still 45 kilograms. So what is the P of 1? How much momentum does she have now? 405? 5 kilogram meter per second. Okay? Does that make sense so far?
Yeah.
So she jumps forward. She increases her momentum, which means the skateboard, where that momentum had to come from somewhere, and it came from the skateboard. And the skateboard goes back. So, if she started with a certain momentum and she ended with a certain momentum, we can figure out what the skateboard's momentum was, right? Okay. The best way to do this is this. Find out what P1 is all by itself, and then find delta P1. That's the best way to do it. Find out what P1 is all by itself, and then find out what the delta P1 is.
405 isn't the P1?
That's 9 times 45?
So is 405 the P1?
Afterwards. It's after she jumps off.
So you have to find
The P1 before she jumps off is 45 times 8.
So 360.
Feels like 360.
Yes, that's true.
360 kilogram meter per second. So she begins with 360. Of the 392, 360 is just her. Okay. She jumps of plus 45? Plus 45 kilogram meter per second. If P1 has a delta momentum of plus 45, then delta P2 would have to be what? Negative 45 kilogram meter per second. So that means if the delta P2 is negative 45, we can find the delta V2. In other words, she jumped forward, increasing her momentum by 45 kilograms, which means the skateboard had to reduce its momentum by 45 or increase it by negative 45 kilograms. So what is the change in speed of the skateboard? Should be like 11 or 12? Negative 11.2?
Yeah.
Does that make sense so far? Okay, let me unpack this. Let me unpack this. She's going forward with a speed of 8 meters per second and a velocity or a mass of 45 kilograms. That means of the 392 that exist overall, she has 360 kilogram meter per second. So far so good? Okay. She jumps forward, increasing her momentum to 405, which means she had an increase in momentum of plus 45. If she jumped forward, increasing her momentum by plus 45, the skateboard had to lose 45. So the skateboard had a change of negative 45 kilogram meter per second. The skateboard has a mass of 4 kilograms, which means the skateboard lost 11.2 meters per second. So far so good? The skateboard's initial velocity was 8. So how fast is the skateboard coming back? Negative 3.2 meters per second. If you want to try to find out what the individual momentums are now and add them together, it's going to equal 392.
That's cool. It's weird.
Weird but cool is what we do here. I think this is the last. Yeah, okay. This is where we're ending today.
So did they pull it up for her?
She jumped. Jump.
Yeah, it almost looked like she's like riding on that crack. It looks like it's like a rope or something.
Okay, so now a question. Okay, so now this is just for fun. Here's a bunch of collisions. Are these elastic or inelastic collisions?
Inelastic.
Very inelastic collisions. Yeah. Okay, and your question?
Okay, so like this weekend, I was looking at fire, and is fire a gas?
I like the way that the apple.
What if my dad says it is? I didn't know if this is physics or not. Like, but what if